All right, in our previous video on system of equations graphing, part 1, talked about just how to graph points, right? If you're given a coordinates, you're given the equation of a line, you can say, look, it starts here, starts at my y-intercept, and then it goes up, whatever my slope tells me to go up, I graph it, and then I have a second line that maybe starts here, and then tells me the slope's negative perhaps, and it looks something like this, right? And then what my goal was to look to see where do they intersect? Where do they cross? And that point is the answer to the system of equations. The answer, the point at which both the x and the y work for both of the lines. Okay, so we went over that and we'll do some more practice with that. But now we're going to talk about special cases. Okay, so if lines intersect, there's one solution. We just talked about that, right? So if lines intersect, there's only one solution. However, if lines are parallel, there is no solution. And if you recall, parallel lines, by definition, are lines that never cross, right? They have the same exact slope, they never cross, so there's no point where they will intersect. So there's no solution for those type. So that's one of the special cases. This is special case number 1. And the other special case would be if they're the same line, then they have an infinite number of solutions. That's the second special case. What do I mean by the same line? Well, if I'm given a certain equation and then the other equation that I'm given is the same thing but just on top of it, that means that they intersect all over the place. Every single point they intersect, so there's infinite number of solutions. So get that into your notes first. So we're going to do an example here. Example number 1 here says, hey, look, I've got this equation, y equals 2x plus 1. This would be like, for an example, hey, it cost me $1 to get into the club and then $2 for each ride after that, right? Or, hey, right off the bat, I owed $3 to begin with, but then I started earning $2. Something along those lines. We're just kind of making that happen. Those would be two separate situations. But anyway, so, or you can think about saving money. Person number 1 had $1 in their account, and then they saved $2 a day. Versus person number 2, they owed $3, and they started earning $2 a day. What would that look like? So what I did here is we're going to go ahead and graph these two. So the red one here, I started at 1, I moved up 2 and over 1, and I graphed that line. The second one, this person started at -3, went up 2 over 1, and crossed. And they say, at what point, when will they have the same amount of money? Well, they'll never have the same amount of money. The lines never cross, and look, they're both saving $2 a day, right? So no one's gaining on the other. But this person here started with $1 versus this one owed $3. So there's always going to be a gap of $4 between them, no matter what the coordinates are. So this one here is a no solution. There's no intersection. The lines are parallel, so therefore there is no solution. Okay, so parallel lines, there is no solution. For our second example, this is going to say, look, I'm given this two equations. They're written kind of differently. So you say, wait a minute, what am I supposed to do here? Well, what I can do is I can rewrite this, right? I can move this negative x and I can add x to both sides. If I add x to both sides, this here will go away. The y is left by itself, and I have a positive x and a positive 1. On the one over here, the blue side, I've got y equals x minus 2 plus 3. Well, minus 2 and plus 3, those are both constants. So you can combine those two. -2 plus 3 is 1. And if you notice, this now is the same equation. These are the same equations. So if I were to actually graph this information, I begin at 1. My slope, remember that little ninja 1, there's the slope right there. I go up 1 over 1. That's the red line. Well, the blue line is the same. It starts at 1, it goes up 1 over 1, and it's the same line. So therefore, no matter what numbers I use, any point on this line will work for both this equation and this equation. So when simplified to slope-intercept form, both equations are the same. When graphed, both lines are the same. The solution has infinite number of solutions. So there's an infinite number because these lines go on forever, infinite. That means that they're going to have all the points that keep on going. There's infinite number of solutions. Any number, any combination that works for one will work for the other. For instance, if I chose, I don't know, let's say I chose 2 for x. 2 plus 1 is 3. Okay, that works over here, right? Because we go 3 minus 2 equals 1, yeah? Then it'll work over here too. 2 minus 2, 0, plus 3 is 3. So it works for both this one here and that one there. And this is just one that I just chose, right? 2, 3, 2, and 3, that's going to be right there. But it could be any point on this line. All right, that's it for your notes for today. We'll do some more examples on our next class. See ya.